Welcome to the August community meeting for Argo workflows and Argo events. Excited to dig into things today. So as a reminder, we have ArgoCon North America in November, so make sure to register for that. I think early registrations ending or normal registrations ending this week, so make sure to register this week to get a better price. And then today we have two demos and presentations. So one about Hera and one about Numaflow. So yeah, I'll hand it over to you, Elliot, to kick off things with Hera.
And there we go, sharing. And so what I want to
Thanks.
share today is a feature that we worked on recently was a collection of decorators that make Hera more like other Python libraries to use. So like Fast API, you kind of set up the service and you add routes on it. The same way we want to do, you write your workflow and you add templates to it rather than the context manager approach that we've used before, because that reflects the YAML, but so it's nice for people coming from YAML, but it doesn't really reflect a normal Python experience. So what this looks like if I get my hello world here. So instead of doing a with workflow and opening a context, instead we're just saying, here's a workflow, and then we're going to set the entry point and tell Hera that this is a script function that we want to write here. So when we write a function like this, we need to have the input and output using the input and output classes from Hera workflows. And then that means the Hera runner behind the scenes knows what to do in terms of converting this user parameter, this user attribute of my input into a parameter. So that's a fairly basic workflow there. And then that's using the script decorator and it matches the old behavior. But now we have things like a DAG decorator. So now this function acts like a DAG by being able to call the other scripts. And if you have an advanced use case like this one, where you're passing parameters between tasks, Hera will now actually figure out the dependencies between the tasks, so you don't have to write out your dependencies like it used to be, which was, oops, like a task A into task B kind of thing. We don't need to do that anymore. Hera will just figure it out. And so if I run this stuff, I have a Docker desktop cluster. So it's building the image of my code, which includes all of this, adding it to my Docker instance. And then I've got Argo running on the cluster as well. So it's just going to run the export of requirements, build the image, and then this script is just launching a bunch of workflows. So now we've submitted them. We'll check on the UI. The initial one I was showing with the hello world, this should have two tasks coming up with the hello and goodbye any second now. Oh no, wait, sorry, this one was just the single one. The DAG was the one with the two basic DAG with scripts. There we go. Hello and goodbye. And the logs should say both. And in the advanced DAG, remember we didn't actually describe any dependencies except for values going from one task to another. So dot results here. And then we have the DAG automatically figured out. And I can show another cool feature we added was this artifact hoisting. So if you have a task within your DAG that you want to lift out the artifact into the DAG itself, all you have to do is specify it as an output of the DAG function. And then this one is called artifact hoisting. Just go and find it. And then this has an output of an artifact, but then so does the DAG. And what this means is when you use the DAG within other DAGs and you say it's now a task, that task, which is actually a DAG, will have hoisted up the artifact that you can use in other steps. So that simplifies that process quite a bit. Any others are interesting to show?
So the DAG hoisting makes it easier to nest outputs Like
Yeah,
DAG
yeah.
outputs. Okay.
So you can have a DAG within a DAG within a DAG, and like you can bring that all the way back up.
And easily pass the artifact through
Yeah,
that.
this one was the artifact
Okay.
passing, which should be here. Artifact passing in the DAG. This one is actually, we're just changing the annotation. It's basically the same as the advanced DAG, wherever it was, except, so these values on the Pydantic objects can be annotated as a parameter, or they're automatically a parameter. And then in the artifacts version, we are just specifying it as an artifact. And with non-archive strategy, it will look pretty similar, except now it's in the outputs, and we can have a look. It's my string, and then at the end, it should be my string, my string, my string, my string. Concatenated it to itself twice. And the other cool thing with the DAG being a function, it means we can run it like locally. So I can run it there. I've passed A and B as my values, and now I get A, B, B, A back, which means it's all locally runnable. The actual feature set is kind of limited, so it's like a first release of locally runnable DAGs that also work on Argo. So you don't have things like expressions and when conditions, things like that. But
This
that's
means we
like
can
a,
easily do this kind of testing on our local without running in Kubernetes cluster, right?
yeah, exactly. Yeah, this was me running on my machine, which was
This is very cool.
this command.
And that's in your Python environment without,
Yeah,
are you running
this
a local Kubernetes cluster or just in the Python?
this is literally in my Python, and then I submitted it to Kubernetes in this file. So this is,
Yeah.
sorry, here, this w.create is connecting to my localhost Argo workflows and submitting them here. So that advanced DAG that we just ran is here. I passed different values, I think A and my value to show I was changing it. And then it was this garbled mess of values.
So, Elliot, can you hear me?
Yep. Hiya.
Yeah, so I have a quick question with the new syntax. With like I noticed that you have like the workflow first, and then you have the DAG. So you go like at w.dag,
Yeah, yeah.
for example. Is there a way of doing like of attaching it later to the workflow, such that I can have like a list of DAG things that I may want to or not put on a workflow?
hmm
Because at the moment, the only possibility I have for using this is like if I define the workflow within this same kind of set of resources. But if I have a DAG that is defined elsewhere, how do you attach it?
Yeah.
Yeah.
That's a feature I forgot to demo today, but it feels like a planted question now that I know.
Yeah.
But
No,
basically,
but
there's a
no.
thing called template set that we added, and this is what you can use to arrange templates across modules. So exactly what you're talking about. If I had W here and I created a new file on the fly right now, template sets, and then from Hera demo, where were we, basic DAG, import W, and then I have a template set. I think I need to do it like this. Oh, I need the that thing. I make a set here, and then I can add a DAG to it if I want by doing this, and then have the same DAG function stuff going on here. So you can create the template sets, and I think I've done this the wrong way around. So basically, you need the
Yeah, you need the
you need a
template set
file
from
of all these template sets, and then in your folder file with this thing, I could do from here demo dot template sets import whatever I called it template set, then dot add template set this thing. There we go. I did do it. We're doing it that.
Nice.
So in this file, you're doing the set of templates, and then in this
Yes.
file, you're creating the workflow.
Brilliant. And how do I chain them?
What do you mean by chain?
So I have two DAGs and one feeds the other, for
Yep.
example.
Um,
like the outputs of one going to the inputs of the other, just because that ended up being the way it made sense to group the tasks.
I think so. If you're just doing multiple DAGs, right, then this would be my other DAG, and it does stuff.
Yeah.
And then here, you'll call my other DAG here, and it will hopefully play nicely. I think it does.
Yeah, but with the template sets, can I put the two things together?
I think I would have to check.
Okay, that's fine.
I'm sure you can, but it's probably
Yeah. No, but that's really cool. I had no idea. It's pretty awesome. Thanks.
that's our new feature from the proposal that was added a few months ago. I had a job change in the middle. Yeah, this. So that's the inspiration, and then our ideas for how you would use it, and then yeah, this is how it actually turned out. Any other questions?
Yeah, one question I had was covering the automated, like where it auto picks up the DAG structure. If you could talk about just a little bit the implementation there and how that works.
So basically when you decorate as a DAG, Hera does like a pre-processing step of running your DAG function. So it can actually look at the calls that you're making, look at the parameters that you're using, and then figure out task A is using the input from here. So that's just like behind the scenes, the double braces inputs.parameters dot value A that's coming from the DAG. And then down here it's using the result of task A. So that's the task A dot outputs dot parameters dot result in YAML land. And then it knows final task has accessed that within its call. So it says final task depends on A, and then it sees the other one as well saying final task depends on B.
Cool.
If I can, yeah. I won't show the code right now.
Yeah, no worries.
Yeah, it's really awesome.
Thank you very much. Yeah, there we go.
Great. Yeah, thanks, Elliot. And I guess if anybody else watching is interested in getting to Hera basics, it's hera.readthedocs, right, Elliot? And then there are some tutorials in there, as well as you did a talk recently, Elliot, so we can put that in the notes.
Yeah, the talk is linked in those docs as well from the walkthrough page, something like Hera tutorial it's called.
Right on.
Good morning. Good morning. Thanks for having me. Yeah, I think the last time I was here and giving an update on Numaflow was like before KubeCon Europe. So we're heading to KubeCon North America. So it's been a while. And we have a lot of features coming in Numaflow. So I would like to give another update here. In case you're not familiar with Numaflow, it's a streaming processing platform running on Kubernetes. You can imagine it's like a workflow running a streaming fashion, right? So I don't want to repeat a lot of basic functionality for Numaflow, but just go directly into the new feature introduction. So the first new feature I want to introduce is called session window reduce. The Numaflow support map and reduce out of the box, and we had a fixed window reduce, slider window reduce, which means you can do things like group by sort of keys and group by period of time. And now we have the new session window reduce support, which means you can do things like group by session window. The typical use case is like you want to do some analytics on the user activity on your website, right? So it's different from the normal fixed window or slider window reduce. There's no fixed starting time or end time for the window. A user can come to your website at any time. They can leave your website at any time, right? So there's not an easy way to determine if the window is closed. Window start properly is easy. As long as there's data, you can tell if the window is started, right? So the only thing you can do is like you can use some sort of duration or timeout. Say, hey, if there's no data coming, we're gonna say this window is closed. So for this kind of use case, the spec is similar to fixed window style. You still have a group by and give a window, and now you have a new field name a session and give a timeout here. So which means, if there's no activity in the 60 seconds in this session, we're going to consider the session is closed. So this is a session window. And the second feature I want to introduce still relate to reduce. It's called windowing in streaming mode. So normally when you do a reduce, no matter it's the fixed window reduce, siren or session window, what do you normally do is like you get the data for that period of time, or for that window, and then you do data processing. You return the message after window is closed. So as a platform, we're going to send you a signal to indicate when it's closed, so that you can process message and return message. If you look at the first function signature here, you're getting a channel. This sort of is in Golang, right? So you're going to get the streaming data into your reduce function, and then you're going to return a list of messages when the function is returned. So that's a normal function signature for reduce. But now we're supporting our streaming mode, which means you get the a channel for the incoming data, and meanwhile you can actually return the message earlier, even before the window is closed. So this is useful sometimes for you. Let's say you want to do some early triggering and send some early data to next vertex so that you can do some early triggering stuff, right? You even do not care about the data accuracy in that case, but so that's the typical use case for streaming mode or reduce. So that's the difference of two function signatures. And the third feature I want to introduce is called fallback sync. It's like a data letter queue support in Numaflow. Numaflow didn't have a dedicated DLQ support. In case you want to do some DLQ, you can use conditional forwarding, which means you can do some sort of forwarding to different branches in case some sort of conditions are not met or are met, just like this. But it did not work for sync. So for sync, for example, you were writing data to some sort of database. And if database is down, we're keep retrying the message. You're keep retrying writing data to the database, and we're gonna make sure the data is not gonna be lost. So we'll keep retrying. But that sometimes you just do some scheduled maintenance for database. Let's give an example like that. And it's not, let's say this the downtime is like 5 hours for maintenance, right? So that's not good to do. Keep retrying the failed message during the 5 hours window. So what you probably want to do is like this, you don't do a DLQ, and then that's why we have the fallback sync here. So spec is something like this. In the sync UDF, you still do a normal sync. Let's say it's still major sync. And if the major sync does not work, we're going to forward data to a fallback sync. It's like a data letter queue support for sync. Yeah, so that's a fallback sync. And another new feature we're supporting for the map semantics. So normally for a map, we're doing concurrent processing to send the data to your UDF or a map operation. So that you're gonna see a datum, which is one message, and you're gonna do some flat map or regular map and return one or n messages. It's like flat map operation, right? But sometimes you want to do batch processing for those messages you received in UDF. And in this case, we introduced a batch map interface that you can accept a message channel. Which means you're gonna get a list of messages, and you're the map operation, and then in the end you're gonna return the batch responses as well. So that's a batch maps support. And then we have something working on. One thing is called a mono vertex, which means it's like running everything in one vertex, one pod. So normally for a pipeline in Numaflow, we have distributed data processing that you're gonna do each step of data processing in each individual vertex, and we're auto-scaling each vertex so that you do distributed data processing, things like that. And now we are introducing a new CRD called mono vertex, which means you run all your source, your transformation, and your sync in one vertex. And then we're gonna orchestrate this one vertex to set the paths. We auto-scale this kind of mono vertex, just like the regular vertex in a pipeline. And all the existing SDKs are still supported, so which means for UD source, UD sync, and UD transformer. Those kind of SDK, you can use those SDKs in mono vertex. So which means you can easily convert a pipeline into mono vertex or mono vertex to pipeline in either directions. You don't need to make any code chain. Just to give another use case. In that case, you don't need to have an inner buffer service in between in the pipeline. You're gonna do like things like one single a vertex or single pod to do all the data processing. And one more thing I want to mention here is like starting from mono vertex, we are actually writing our data plane in Rust. So we have the control plane, everything was in reading Go, and then now we're switching our data plane to Rust, which will bring better performance. And then you can see for this mono vertex support, we can easily get like 75K transaction percent. That's kind of throughput. We also have another project named the Numaflow running. It's still under development, which is this Numaflow is going to be something like on top of Numaflow is used to manage like Numaflow pipeline life cycles. So it's like if you use Numaflow, you're gonna get the benefit of seamless upgrade for Numaflow controllers, UDF image upgrade, those kind of things, and you're gonna support a progressive rollout and rollback. And we're gonna have Argo CD integration with Numaflow, which means so this Numaflow will introduce some sort of roll object on top of the pipeline. For example, pipeline will have a corresponding pipeline roll object, so that can be supported to do like progressive rollout or rollback, those kind of thing. And we're going to have Argo CD integration, which means for pipeline rollout and this kind of roll object, we're going to have the dedicated pop-up window when it shows up in the Argo CD page, and you're going to see more information on the roll objects. So those are the new things we're working on. And yeah, I think that's all the update I want to give here. I don't want I don't want to give too much in the details, but if you have any interest in Numaflow, just you can come to our website or just look at our poster and take a look. Thank you. Any questions?
Thanks, Derek.
Thank you.
Yeah, any other questions? Yeah, Derek, you all have been very busy. That's exciting. Yeah, what was the use case behind the mono vertex? I was curious to hear, yeah, why to use that.
Yeah, the mono vertex is like sometimes you don't need to in the buffer service. Right now, the buffer is like message queue sitting in between the vertex pipeline. That interests latency. That's right, because there's one more hop in between. But that is very useful when we do some message persistent. If you have some high latency message processing, right? Let's say you are doing inference or training, it takes a long time for the message processing. It's good to have those kind of buffer service and this messaging in between. But sometimes, let's say you want to do, if your business logic is very simple, just to read some message from, let's say from Kafka, and do a very quick transformation and then write to a sink. And you probably do not need to have an inner buffer service. And you want to achieve low latency, and so that's a use case for mono vertex.
Got it. Okay. Yeah, that makes a lot of sense. Nice. Well, I think that, yeah, wraps it up for today then. Yeah, thanks, Elliot and Derek, for presenting. And we'll get this up on YouTube and see y'all next month for another community meeting. Have a great day.
Thank you. Thank you. Have a great day.
Cheers.